sewer pipes and service lines. The Herrenknecht ABN series introduced in this film has been deployed successfully on every continent. The advantages of the pipe jacking and micro-tunneling process are evident. Especially in urban city areas, pipe jacking causes minimum disturbance along the construction route, so there is virtually no disruption to the flow of traffic or any impact to the local economy. In contrast to conventional methods in such construction projects, pipe jacking and micro-tunneling has an environmentally friendly method and helps to conserve protected landscape areas. The following animation shows the installation of new sewer pipes within a diameter of 600 mm in an urban crossroad with dense traffic. The whole construction site can be located in a way that only one lane is affected. In our example, 150 meters of sewer pipes are to be jacked from the launch shaft to the reception shaft. At the first stage, the area around the starting shaft is cordoned off and the traffic is diverted to the remaining lanes. Due to the compact design of the machine and the small diameter of the starting shaft, there will only be minor disruption to the traffic flow. In this case, the start shaft consists of a round shaft of reinforced concrete with an inner diameter of 3.2 meters. The compact jacking frame is then placed into the starting shaft, and the slurry discharge pump is mounted on a platform adjacent to the jacking frame. The operating container with the control panel and the hydraulic power pack is located on the top rear side of the shaft. A pipe stock is then established and maintained in front of the shaft to feed the shaft crane. The slurry feed pump and the slurry discharge pump are connected to the settlement tank to form a closed slurry circuit. The ABN 600 machine consists of several segments. A sleeve shaft with 3 boreholes connects the cutting wheel with the drive unit. The mix of crushed material and slurry water is sucked off through these boreholes by the discharge pump. The conical crusher situated in front has reinforced crushing bars and is provided with nozzles to inject the slurry water. The sleeve shaft, which is connected to the cutting wheel, is driven by hydraulic motors. The sleeve shaft is seated in a tapered roller bearing. 3 hydraulic motors transmit the rotation via the gear rim to the sleeve shaft and the cutting wheel. 3 steering cylinders enable the operator to correct the direction of the tunnel boring machine, as well as control the alignment of the machine in curved drives. Therefore, the position of the cutter head is continuously updated with the help of the laser guidance system. To ensure ABN 600 has a smooth method of excavation, the machine has 2 integrated water circuits. The standard circuit supplies slurry water to the annulus via 5 hoses fixed to the inner side of the bulkhead. Several boreholes branch off from the annulus, which supply the chamber situated behind the conical crusher. The slurry water is continuously pumped through the conical crusher chamber, sucked off through the boreholes of the sleeve shaft and transported back to the settlement tank by the discharge pump. A second hose supplies the high-pressure nozzles used in the conical crusher. These nozzles avoid clogging and agglutination in the crusher chamber in case of cohesive soils. They cut the clay in the crusher chamber with 250 bar water pressure and consequently make material transport easier. There are also 2 nozzles that are directed to the front part of the cutting wheel. This totally depends on the geological situation, as the number of nozzles can be increased. The water coming from the nozzles is mixed with the water of the slurry circuit and the excavated material. The whole mix is then transported to the settlement tank. The cutting wheel excavates the material at the tunnel face. In the crusher chamber, the material is grinded down to the appropriate grain size by the spokes of the cutting wheel, which operates in the same principle as a coffee grinder. Large stones are crushed by the discs of the cutting wheel. Sometimes, fragments are being displaced to the surrounding soil. stones attaining the crusher chamber through the openings of the cutting wheel are crushed by the reinforced conical crusher and the spokes of the cutting wheel, and afterwards transported together with the slurry water to the surface. The material is picked up in the slurry circuit and transported to the settlement tank through the central slurry discharge hose. The slurry feed and discharge lines are passing through the jacking pipes via the jacking frame up to the surface. The slurry discharge pump removes the excavated material and pumps it up into the settlement tank, which consists of 2 chambers. At first, the excavated material is pumped into the rear chamber, where it settles due to gravity. The overrunning water is collected in the front chamber, from where the clean water is sucked by the slurry feed pump and returned to the slurry circuit, thus creating a closed system. The product pipes are lowered into the shaft, one after the other. The jacking frame works in 3 stages. After approximately 1/3 of the maximum jacking stroke, the jacking arms return and the main thrust ring of the jack can advance further. After jacking the product pipe, all supply lines, such as hydraulic hoses, are disconnected. The jacking frame is returned to its original position and the next product pipe is lowered. This procedure is repeated again and again until the whole drive length is completed, reaching the reception shaft. Crossing pipes and buildings can easily be overpassed or undercrossed with this technique. Thus, the machine arrives in the reception shaft exactly at the planned coordinates. The drive is continuously monitored by a laser guidance system. The laser itself is positioned in the starting shaft, meeting the laser target, which is installed behind the cutter head. The laser beam determines the reference axis. The laser target identifies any deviation which may occur. The coordinates are transferred to the steering computer in the container and visualized on the screen. Any deviations in position can be corrected by adjusting the steering cylinders at the push of a button on the control panel. The length of the tunnel is recorded by a metering wheel. This information is transferred to the control panel and allows the operator to determine the location and direction of the machine cutter head at any time. In our example, the total of 150 meters of new pipes could be realized with only a minimum of disturbance in a sensitive infrastructure. The conventional open laying of pipes would have caused major disturbance and annoyance for traffic and the residents. Knecht, being the leader in technologies for mechanized tunneling, has both the know-how and the experience to realize every tunneling project. Throughout the world, the company, with its headquarters in southern Germany, is the only supplier offering the entire range of tunneling machines, with diameters of 100 millimeters up to more than 14 meters. Hard rock TBMs, EPB machines, mix shields, and machines with partial face excavation, as well as pipe jacking and HDD equipment manufactured by Knecht, successfully realized mission breakthrough all over the world. More than ever before in history. Vital resources such as drinking water threaten to run short due to the ever-growing industrialization and the population development. Urbanization continues to expand. Innovative and sustainable sewer systems are a decisive factor for the quality of life in the large cities. Even state-of-the-art wastewater treatment plants produce up to 5% of sludge when treating water for domestic and industrial use. Recycling of this sludge is not possible. How can it be disposed of? Dumping the effluents in landfills increases the risk of pollution of our valuable groundwater. Cities near to a coast are able to drain the effluents into the sea, thus not causing ecological harm. Previous methods were limited by the technologies which were available. Pipelines leading into the sea were constructed above ground, lowered onto the sea bottom and loaded with ballast. These pipelines were much too short and shallow. As a result, the effluents are washed back ashore, causing a lasting pollution of the ecosystem. The pipelines that were lowered to the sea bottom and loaded with ballast do not withstand the impact of the currents. During a storm, high waves produce hydrodynamic forces which often result in erosion and washout, which eventually destroys the pipelines. The solutions, called sea outfall, are preferred from the ecological point of view. However, with conventional construction methods, they cannot be realized in the ideal way. But using Herrenknecht's state-of-the-art micro-tunneling techniques allows for sea outfall pipelines which can be jacked as far as possible and deep under the sea bottom, in nearly every geological and topographic condition. The following computer animation shows the construction of a 1.4 kilometer long sea outfall pipeline into the open sea using the pipe jacking method. Here you can see the old, rather short pipeline ending at low depth in the harbour. As a result of the weak current in this area, the effluents cause severe pollution in the harbour area and coastline. In the future, wastewater shall be disposed of via a newly planned wastewater treatment plant. From a pump station, the raw effluent is pumped through a pipeline to the onshore shaft, from where the new sea outfall pipeline shall be jacked. The shaft is usually located in the coastal area, which protrudes furthest into the open sea. As the pipeline itself is planned to be 1.4 kilometers long, each meter of gained ground is of advantage, thus leading the wastewater further into the open sea, where the currents can wash it away from the coast and the city. The recovery of the machine will take place at the reception pit, 1.4 kilometers away from the onshore shaft. Herrenknecht micro-tunneling equipment is perfectly suited for rock and mixed soil conditions under groundwater. The pipe jacking job site consists of the onshore shaft, the jacking frame, pumping systems for slurry material removal, separation plant, pipe stock, and an operating container from which the machine is controlled. This onshore shaft was constructed with sheet piles. It is approximately 8 meters deep with an inclination of 8 degrees. The rotating cutting wheel excavates the material at the tunnel face. Rock and stones are crushed by the discs of the cutting wheel and then ground down to the appropriate grain size in the cone crusher situated behind the cutting wheel. The material is picked up in the slurry circuit and transported to the separation plant through the slurry discharge line. This line passes through the machine and the jacked pipes up to the surface. In the separation plant, the excavated material is separated from the water. The machine and the pipeline advance continuously with the help of the jacking frame and intermediate jacking stations. The movable cutting head of the machine is controllable and thus enables the jacking of curved pipelines. So the rocky coast and reef can be undercrossed before the pipeline is jacked horizontally to the arrival point. To keep the jacking forces of the jacking frame as low as possible, the so-called intermediate jacking stations are used during this long-distance pipe jacking. Every intermediate jacking station only jacks a section of the pipeline, so the required jacking forces can be kept at a low level. With this method, it is possible to realize long-distance pipe jacking. The reception pit is located 25 meters below the water surface. A barge is positioned above the arrival point of the machine and is kept in its position by mooring lines and a ship. At the arrival point, a reception pit of approximately 20 meters length is excavated. A crane loads the excavated material onto a ship docked to the barge. Part of the soil covering the machine is excavated, the rest sucked away by a scuba diver and separated in a settlement tank on the barge. The machine is hermetically sealed and kept under overpressure, thus preventing seawater from entering the machine during the recovery. The pipeline is flooded with water from the onshore shaft. A diver assembles a crossbeam to the machine. Four hydraulic cylinders are installed in the rear part of the machine. To separate the machine from the first product pipe, the hydraulic cylinders are extended. The recovery itself can begin. The complete machine is lifted by the crane and put on a frame on the barge, which returns the tunnelling machine to the harbour. The diffuser itself consists of prefabricated reinforced concrete units. These are lowered into the reception pit and connected to the pipeline. Afterwards, the pit is filled up. A depth of approximately 25 metres below the water surface is sufficient. The pollutants are rapidly washed away by the currents near the sea bottom. A large quantity of seawater is available to dilute the concentration of the sewage plume before it reaches the surface or deposits at the sea bottom. If the wastewater is discharged at a sufficient distance from the coast using sea outfalls, the danger of serious pollution is considerably lower due to better dispersion, diffusion and decomposition. Furthermore, these processes can be improved with the adequate construction of the outlet. In the mixing zone, the concentration of pollutants already decreases by a factor of 1 in 100 due to the dilution, thus no longer being ecologically harmful. With the new sea outfall pipeline, the wastewater system of this city near the coast could be considerably improved. The unpolluted sea nearby the coast is of advantage for both man and nature. Due to the fact that the pipeline lays underground, it is safe and maintenance-free for decades. Another advantage of a tunnelled sea outfall: the coast and accordingly the people are not affected. This procedure is environmentally friendly. Construction works do not depend on the climatic influences, such as waves, storms and so on. For the cities close to the coast, Hare & Knecht's state-of-the-art sea outfall technique offers an excellent possibility to lay the foundation of a modern, cost-efficient and environmentally friendly wastewater disposal. The water quality of the sea, ocean and beaches will be improved.